Today we're going to talk about dimensional analysis. With dimensional analysis, you take a given unit and you convert it to a desired unit using a conversion factor. The steps to use is first, you determine which conversion factors that are needed. It can be one or more. Carry your units throughout the problem. Then if all the units cancel except for the desired units, then the problem was solved correctly. Then determine the significant figures at the end. So you see at the bottom, you have your given unit, and you take that conversion factor, which is this like fraction, and you orient it so that the given unit is lining up with that in the denominator of the fraction, leaving your desired unit in the numerator. So we get conversion factors from equalities. For example, 1 inch is 2.54 centimeters. Written as a fraction, or you can say ratio, with a numerator and a denominator. Inverting it will give you two conversion factors for each equality. For example, if you have 1 inch equals 2.54 centimeters here at the bottom, you see that the 1 inch is in the numerator on the left, and on the right, the 1 inch is in the denominator. Some common equalities you should study, and the more practice problems you do, you'll eventually get very used to these and probably memorize them, are here. For example, 1 foot is 12 inches, 1 mile is 5,280 feet, 1 yard is 3 feet, 1 hour is 60 minutes, 1 minute is 60 seconds, 1 liter is 1,000 mil, and so on. Well, see if you can take these equalities and convert them in their conversion factors. Each one, A, B, and C, should have 2 answers. Go ahead and pause if you want to try it before seeing the answer. So here's the answer. For A, 1 liter to 1,000 mils, you have the 1 liter on the numerator, then 1,000 mils in the denominator, and then you just flip it. Then those are the 2 conversion factors for the equality in A. B, you have 1 hour in the numerator, then 1 hour in the denominator. And C, you have 1 kilometer in the numerator again on the left and the denominator on the right. Let's look at an example. A rattlesnake is 2.44 meters long. How many centimeters long is the snake? So you start with what's given in the problem. It says the rattlesnake is 2.44 meters long. So first I would write that down. And then it says I'm converting to centimeters. That's what I'm looking for. So that's my desired unit. So you start with meters. I would write 2.44 meters down. And then the times symbol. Then you pick a conversion factor so that the given unit cancels out, leaving the desired unit. So in 1 meter, there's 100 centimeters. Meters cancel, leaving centimeters in the end. You multiply, you get 244 centimeters. And then make sure that's the unit you want. It is. Then look at sig figs, or significant figures. That's what that 3SF is for. So with equalities, which give us a conversion factor, those are exact. Remember from learning about significant figures. So therefore, I can just look at the significant figures and what was given. So the 2.44 has 3 sig figs. So that is what's going to be in my final answer. 244, and I'm good. Another example, how many minutes are in 2.5 hours? So first thing I do is figure out my conversion factors. You need to go from hours to minutes. And then 2.5 hours are given, so we'll start with that. And write our given down, the 2.5 hours, then the time symbol, then put in our conversion factor. 1 hour is 60 minutes. We have it so that the hours on the bottom, so that the units cancel. Minutes is on top, given the desired unit we want it. Therefore, we end in 150 minutes. Sig figs, again, the given unit has 2, so we'll want 2. 150 has 2 sig figs. Last example. The speed of sound in air is about 303 meters per second. What is the speed in miles per hour? So again, we would look up conversion factors. You can go back to that table, or you can Google some if you didn't know them from off the top of your head. Then I'm saying, okay, I'm going to write down first 343 meters per second, and then carry out my units. I'm going to start with the top one, meters first. You can start with the top or bottom. So in 1,000 meters, there's 1 kilometer. So that cancels out meters. And then in 1 kilometer is 0.621 miles. So make sure kilometers on the bottom on this conversion factor, so kilometers can cancel out with kilometers in the previous conversion factor. We have miles on top, that's what we want, so that stops. Now we go to seconds to get to hour. So in 1 minute, there's 60 seconds. We put seconds on top, so that those units will cancel. And then for the next conversion factor, 1 hour is 60 minutes. Again, we put minutes on top, so minutes will cancel with the conversion factor on the bottom and the previous conversion factor, leaving hour on the bottom, which we wanted. Then we go through and carry out our math, which I'm going to bring up my calculator for that. So we got 343 divided by 1,000 times 0.621 times 60 and then times the last 60. 766.8108 is what I got in this calculator. And notice again, I just left all the numbers in there until the very end. And then that's when you'll do your rounding. So I want 3 sig figs. I looked at the given unit for that because conversion factors are exact. So 766 was in the calculator. I rounded up because it was 0.8 behind that last 6 there. 767 miles per hour. Got my 3 sig figs. I'm done. Make sure to like and subscribe if you like what you see, and leave a donation. Even $1 helps, and so I can continue to make these videos.